What's up, everyone? Now that we know a little bit more about sine and cosine graphs, let's get into some examples with them. In example 1, we're asked to, for the following curves, state the amplitude, equation of the principal axis, the period, and the phase shift or the horizontal shift. So let's just first list out everything we need. All right, so we're looking for the amplitude, which I just labeled as amp, the equation of the principal axis, which I'm shortening to PA, our period, and our phase shift, which I'm shortening to PS. So what might also be helpful is not just listing out what we need, but also labeling what we have here. So we have A out front, B as the 1/2, C as 4, and D as the -5 at the end, just so that we can kind of connect it to all of those letters that we had already talked about. So the amplitude, remember, is the absolute value of A, which in our case would be the absolute value of 2, or just 2. The equation of the principal axis, remember, equation means you have to have the equal sign. So we had already said that the equation of the principal axis is y equals d, which in our case means y equals -5. Box some of these up. The period we can write in two different ways, especially if it doesn't specify which mode we should be in. We had talked about how the period can be 2 pi over b if we're in radians, or 360 over b if we're in degrees. Since they don't specify in here, we would accept either, or the answer key would be either one, would be perfectly fine to accept. Since the problem doesn't specify, either one would be accepted, either your answer in degrees or in radians, whichever one you're more comfortable with. But let's find both just to get some practice. So my B value is 1/2, which means my period in radians first would be 2 pi divided by 1/2. Just like any other problem, that looks a little bit messy, so we shouldn't leave our answer like that. What we can do is, depending on how comfortable you are with dividing fractions, remember that you're just multiplying by the reciprocal, so keeping the numerator, changing to multiplication, and flipping the denominator. Or if you want to check your answer in the calculator, if you just want to do it in the calculator, leave the pi out of it, because especially if you're in radians, usually pi will be part of your answer. So we'll leave the pi out of it and just do 2 divided by 1/2 in the calculator. Either way, we should be getting 4 pi. If I wanted to do 360, if I wanted to do degrees, so 360 over 1/2. Same thing, you rarely end up just multiplying it by 2. So we're getting 720. Finally, the phase shift, remember, is the same thing as the horizontal shift, and C tells us how much we're shifting, and then we need to remember the directions. So just like with horizontal shifts with any other function, phase shifts are always the opposite of what they appear to be, in the sense that I have x minus 4 in parentheses here. So I would say this shifts to the right by 4. And that's it. All right, for example 2, for the function y equals a cosine bx plus d, the graph y equals f of x is drawn where x is given in degrees. First, we are asked to state the equation of the principal axis. Remember, the principal axis, we had said, is that line around which the graph oscillates. So we can find it by finding basically the average of the y values of the max and min points. So for our graph, what that means is I'm doing the y value of the max plus the y value of the min divided by 2. So 3.5. Note that it does ask for the equation of the principal axis, though, so I'll want to set that equal to y before I box it up. So that means my principal axis is right around this line. Hence, find the value of d. So we had already said that d is the equation, or it gives us the equation of the principal axis. And we also have to remember that hence means we just found something in the previous step that will help us find this answer. So in this case, it's literally just changing a y to a d. D does equal 3.5. Part C of the same problem, finding the amplitude of the function. So the amplitude, remember, is the distance from your principal axis to the maximum or the distance from it to the minimum. So you can either look at it, since we have the graph, we can look at it from the graph. If this is 3.5 up to my maximum point, that's 2. That's a distance of 2. Or from my principal axis down to the minimum point, 3.5 to 1.5, that's also a difference of 2, or distance of 2. So I can find it that way, or just like how we had said in the other video, we can find the difference between the y values of the max and min and then cut it in half. And so if you wanted to, you could use this formula where you sub in the y value of the max, the y value of the min, like I said, cut it in half. Just remember that we are looking at the absolute value of that, especially if you switch the min and the max. It's just to ensure that it doesn't matter which order, but it also gives us a positive value. But either way, you should get that the amplitude is 2. Part D, hence find the value of A. So again, just like our principal axis in D, that when I find my amplitude, that is my value of A. We had said before that A, the absolute value of A, is the amplitude. So I can just say that A equals 2. I don't know for sure yet if it'll be positive or negative, but I can always come back and add in a negative if I need to. Part E, finding the period of the function. So the period, remember, is the horizontal distance that it takes for the function to start repeating itself. So lots of different ways you can find this. It really depends on the graph that you're given. For this graph, we're given a large portion of it, so it is helpful that we have that much of it. But we can, option 1, find maximum point to maximum point, the horizontal distance between the maximum points. That'll get us the period. We can do the same idea, but minimum to minimum. So the difference, the horizontal difference or distance from the minimum points, or two minimum points back to back. Or let's say we didn't have this part of the graph or this part of the graph. Let's say we only had this little portion. You can take the horizontal distance from max to min or min to max and just double it. It'll get you the whole period. So let me write out those options and then write out what our answer is. All right, so in our case, if I wanted to go, let's say just max to max, just because it's easy and I can see it, my first maximum point is at 0, x value, and my next maximum point, x value, is at 120. So the difference between them, or the distance, is 120. Remember, we are in degrees here, so I should even add in that degree symbol at the end. If you felt more comfortable, since these are the only 2 points that are actually labeled, I could find the distance between them. So I'm going to start with the larger one first, 120 minus 60, and then double that. And I'll still get the 120 degrees. So it really just depends on what you're given in the graph, and then from there, what's labeled accurately for you. Part F, hence find the value of B. So when we found the principal axis, it was D. When we found the amplitude, it was A. But with finding the period, it is not automatically B. Remember, we said before that the period equals, in terms of degrees, since we're in degrees here, the period equals 360 degrees divided by B. So that doesn't automatically mean that whatever our period is, that's what goes in for B, or that's what equals B. What we'll have to do instead is, since we know 120 is the period, we'll sub in 120 for the period and set that equal to 360 over B, and then solve for that. All right, so I went ahead and put the 120 over 1 just to cross multiply, or you could multiply both sides by B, and then divided both sides by 120. So that means B should actually equal 3, not 120. So very important to recognize that A and D, whatever you find for the amplitude and the principal axis respectively, can just be subbed in. But your period, you do have to do some work in order to go from your period to whatever the B value is. All right, and finally, final step of example 2, all leading to writing the equation y equals a cosine bx plus d using all the values that we found, or all the information that we found in parts A through F. So if you need to kind of scroll back or go back through your work, and we're just going to put it all together. That's it. So we found our A value, the amplitude, to be 2, cosine. I'm just following this setup for us. B, we just found our B to be 3. So that's going in parentheses with our X. And we found our principal axis, or our vertical shift, to be 3.5 or 3.5. So I said with our amplitude a while back that we may need to add a negative with it. If you recall from the parent function for sine, it starts at a maximum and makes this kind of U shape, just like our graph does here. So because of that, we don't need to add a negative with the 2 at all. This is just our answer. If instead it looked something like this, where it started at a minimum function and made an upside down U, that's where we would need the negative inside, or a negative with the amplitude. But because we don't have that, we are good to go with a positive A value.